blast furnace there. They're heating up the bronze, melting it down, and then heating it up to a temperature of just a little over 2,000 degrees. Okay, they've got the molds of a new beginning inside this furnace here, where they heat up the molds to match the temperature of the bronze, so that we get an even flow of bronze. It also melts the wax out of the mold, which leaves a cavity inside the ceramic shell. What he's doing now is checking the temperature of the bronze. He sticks a thermometer down inside. Who is also the mold maker, said that the bronze has to be about 2,050 degrees before they pour. If you've never felt 2,000 degrees, you have no idea. Now they're getting dressed up because that bronze splatters on you. You better be protected. The molds have to be about 1,600 degrees, and they're picking up with their hands, so you can imagine the kind of gloves they've got. There are the molds. That's with the cup down. That's the pouring cup on the bottom. That's the horse right there of a new beginning, and they're hanging it by the cup on these hooks. Now it's hollow inside. Okay, go ahead. I gotta tell you, that feels really hot right now. Now they're getting the plug off the top of it. Now they're going to pick it up with this device, and they'll carry it over and start pouring. What he's doing, he's getting ready to put more bronze into the crucible so they can melt it down. All right, they're starting up the furnace again. It'll take about an hour for that to melt down. Now, let me show you what it looks like inside the molds right now. Okay, that's the horse from this piece called A New Beginning. And this is the mountain man coming out now. They're bringing him out here to cool off. They're spraying it with water just to cool it down a little bit faster. Why do you spray water? All right, the reason he's spraying water on it is because it takes out the hot spots. You don't want the bronze to cool unevenly, because then if it does, it cracks or it bends or just distorts. more molds out to start cooling, heating them up. And there's the Indian woman from my piece under his arm there. That's the base for the mountain man and Indian woman, and that's the Indian woman right there. So they've got the molds in there. Now they'll close up the oven. And then they'll start melting out the wax. All right, you can see the smoke. And now we've got wax flowing into the pan. You can see that starting to fill up now. Now you can see the mountain man starting to emerge now. So anyway, you can see how it's coming out of the mold now. Now this is the horse here. This one's wrapped in chicken wire to give it strength. All right, I think that gives you the idea of what happens, and I'm going to let it go at that because he has to get back to mold casting, and I've got to get home. So that's it for today here at Northwest Art Casting.
Hello and welcome to A.W. Bell, the company who can turn your ideas into metal. Established in 1952 as a pattern works, A.W. Bell has grown into a modern manufacturing facility offering a wide range of metalworking services. We offer a complete service from concept all the way through to finished product. A.W. Bell's in-house rapid prototyping process involves the use of 3D printers that can print wax and then incorporate the investment casting process to develop the finished product. Rapid prototyping enables us to be responsive to your need for fast, accurate metal parts. This process is ideal for small runs which can be delivered in as little as 2 weeks. Parts are produced from your CAD data, giving you control of the final part shape. The parts are inspected throughout the production process to ensure final size is as close to your specifications as possible. Rapid prototyping allows us to supply models in any material we cast, saving weeks and dollars at the development stage. A.W. Bell's investment casting process is ideal for creating near-net shape metal parts that require minimal machining, finishing or surface treatment. This saves time, money and material. Investment casting can produce complicated multiple part assemblies that are otherwise expensive or difficult to fabricate. The investment casting process begins when wax replicas of the desired part are produced by injecting wax under pressure into a die. Depending on quantities required, we can use either a manual die for low volumes or fully automatic die for high volumes. The wax pattern is then attached to a wax tree, which is also the runner system for the flow of metal. The tree is dipped into a ceramic slurry and then into a bed of extremely fine sand. Up to 8 to 9 coats may be applied in order to get the desired shell thickness of approximately 6 to 8 millimeters. Once the ceramic is dry and a desired shell thickness is achieved, the wax is melted out using a boilerclave. This leaves a negative impression of the part and runner system within the shell. The shell is placed in an oven where the last remaining wax is burnt out and the ceramic shell is fired. Before casting, the shell is preheated and then placed into a fluidised sandbag. The metal, which is melted in an induction furnace, is then transferred to a ladle and gravity poured into the preheated shell. After the molten metal has cooled, the ceramic shell is removed by vibrating or high pressure water blast. The castings are then removed from the tree through the use of high speed cut-off saws. The gates are then removed on a manual linishing machine for low volumes or an automatic linishing machine for high volumes. Some castings require a minimal amount of hand finishing or gauging at the inspection stage. A.W. Bell's sand casting facilities include a new mould line which is set up for low volume production quantities. Our flexibility allows us to be able to cast almost any metal, ferrous or non-ferrous. The mould line is currently manufacturing sand moulds for sand casting production and prototype parts for the automotive industry. A.W. Bell's pattern shop can produce highly accurate wood and Uriel patterns. We have the ability to produce general foundry patterns, production resin foundry patterns, zinc spray tooling for our investment casting facility, small to very large foam patterns for the press tool industries, and complex prototype patterns for the automotive industry. A.W. Bell has a comprehensive tool making facility providing flexible solutions to your tooling needs. We use a variety of technologies including CAD/CAM, CNC machining, pattern making and rapid prototyping to provide tooling to meet your lead time and budget constraints. A.W. Bell is a premier supplier of tooling for diesel machines, production sand casting, gravity die casting, wax injection moulding and other industries. A.W. Bell's production machining facility provides precision finishing of our castings to meet tight tolerance requirements. We can handle both continuous and batch production machining of parts large and small. Bell Machinery manufactures specialised grinding machines and abrasive cut-off machines. Our grinders are ideal for repetitive grinding of castings in investment, die casting and sand casting foundries. A.W. Bell strives for continuous improvement in quality standards. Ongoing investment in state-of-the-art production, inspection and control equipment allows us to produce components with high accuracy and repeatability. Our accreditation in ISO 9001 and ISO 14001 reflects our dedication to quality and the environment. Our commitment to quality ensures that the parts we manufacture meet your specifications. The 3 CMM machines run by our quality department are just a part of A.W. Bell's comprehensive quality strategy. To contact us for further information, log on to www.ideasintometal.com.
Investment casting patterns are made by injection molding. These patterns are assembled onto a wax post connected to a pouring cup. This pattern assembly, called a tree, usually incorporates complex runner systems to assist metal flow in the investment casting process. The shell mold is produced by dipping the pattern assembly several times in slurry and allowing it to dry between dips. The first slurry mixture consists of fine particles for smoothness. Subsequent dips are mixed with coarse particles to quickly build up thickness and provide strength. The wax is removed from the mold by melt-out in a furnace or autoclave. Then the mold is fired to remove moisture, cure the ceramic, and to preheat it for pouring. Both ferrous and non-ferrous metals can be investment cast. Once the metal has solidified, the mold is broken and the casting removed. The main advantage of investment casting is the complexity of shapes that can be cast to close tolerances, thin walls, and smooth finishes.
The master model can be made of almost any material, metal, wood, or any of the current modeling techniques. Anything which won't hinder the silicon rubber from hardening. Tape is placed on the master and colored to form a split line that will be visible through the silicon rubber. The master is then suspended in a casting frame and rods inserted to form the gate and provide venting during casting. MCP silicon rubber is mixed under vacuum, then slowly poured over the model. The frame is placed in the vacuum chamber and allowed to defoam until all air bubbles are removed. The silicon rubber is cured in the oven, then opened to reveal an exact replica of the master model, a silicon tool. To cast a prototype, a release agent is applied to the surface of the tool, and the two halves clamped firmly together. After warming in the oven, the tool is placed in the casting chamber. Resin components are carefully measured, and colouring pigment added if required. The resin is then mixed to a programmed cycle time. When the vacuum reaches maximum level, the two components are automatically mixed together. And the resin cast into the silicon tool. The vacuum is then leaked, and the incoming air pressurizes the resin to ensure complete filling of the cavity. When fully cured, the prototype is carefully removed, and the tool ready to be used again. Hand finishing is necessary to remove the vents and gates. The result is a prototype of high quality with a flawless finish. Proven materials, thorough training, and ongoing technical support gives you consistent quality every time. Insist on the best.
The cold chamber machine is used primarily to die cast the aluminum, magnesium, and copper alloys. In the cold chamber machine, the charge is supplied by ladle or feed system from an external furnace source to a holding pot at the shot end of the machine. The feed system components are not submerged in the molten metal. The charge is poured ahead of the plunger tip through a pore hole in the shot sleeve. As the plunger advances, it closes the pore hole and drives the molten metal into the die. Injection pressures may range to 10,000 pounds per square inch or 69 megapascals for aluminum and magnesium, although some machines can provide still greater pressures. After the metal in the die solidifies and the die halves are separating, the plunger thrusts forward, extending the plunger tip past the cover die. This pushes the biscuit that solidifies at the end of the shot sleeve, assisting casting release.
RD Castings, an independent family organisation experiencing over 30 years of continuous growth in a highly competitive market. Supplying to a vast market sector, including the rail industry, automotive, architectural and product development in the aerospace industry. The company prides itself on customer focus, from die design stage and prototype development work, utilizing full CAD/CAM 3D modeling, right through to finished CNC machined, painted, plated, assembled and tested products, always with a keen eye on continuous improvement. Advising on component design, which enables the very best results, accepting data in many forms, including IGES, AutoCAD, DXF, Parasolid and STEP, to name but a few. RD Castings has an extensive in-house tool room providing the design and manufacture of CNC jigs, fixtures and precision press tools. These facilities provide for a high standard of maintenance to all customers' tooling. Supplying both aluminium and zinc die castings in many different material specifications from 10 grams to 10 kilograms. The vast range of machines varies from 30 to 400 tons, including computer-controlled technology enabling flash-free castings, and with the added ability to vacuum cast, ensuring virtually porous-free castings. A process suitable for short, medium and long runs, sufficient to cover the needs of every customer now and in the foreseeable future. At RD Castings, secondary machining operations are carried out on Brother high-speed twin-pallet machining centres fitted with high-speed Nikon 4th axis. All machines are programmed offline with a DNC link to increase productivity. Alongside our CNC milling department, we have a new CNC turning section incorporating the latest Mazak Quick Turn 250 turret lathe, covering all turning requirements. Castings are finished with the aid of a fully automated vibration system and a fully automated shot peen machine. Collectively, these facilities have enabled customers to benefit from great savings over other conventional methods of manufacture. RD Castings employ the latest high-tech computerized inspection facility, including a 3D coordinate measuring machine fitted with the latest Mitutoyo software. X-ray scanning can be arranged where required, along with full SP and CPK stats, all of which are carried out in accordance with BSEN ISO 9001, along with a total commitment to the environment. Utilizing their own fleet, RD Castings distributes nationwide as well as globally via international carriers, a company dedicated to quality and customer service, delivering straight to line side when required, a complete all-round service. Kanban and JIT supplies are also available, ensuring complete customer satisfaction. RD Castings, casting a good impression around the world.
Centrifugal casting is a metal casting process that produces a very high-quality product. Spuncast Incorporated is an industry leader in this field due to its commitment to quality and service. Since 1976, Spuncast has been using the centrifugal process to cast steel and stainless steel tubing, roll bodies, flanges, hydraulic cylinder bodies, and much more. The spinning casting fills any shrinkage voids under high pressure from centrifugal force. Slag, dirt, and dross, being of lower density than the metal, spin to the bore or set. The result is a very clean, very dense, very uniform casting. Once the casting is complete, the tube is machined to remove the impurities that spun to the center during the casting process. Spuncast uses its vast metallurgical expertise to partner with its customers to improve products and processes. Spuncast gauges its success by its ability to contribute to its customers. Solutions are what customers want, and SpunCast delivers on time, every time. That's what keeps existing customers coming back for more and brings new customers in the door. SpunCast has been ISO certified since 2003. In August 2009, SpunCast upgraded its quality systems to the ISO 9001-2008 quality certification. Continuous improvement is very important to SpunCast, from operations to customer service. SpunCast's future is about growth into new world markets. This means successfully competing in the global marketplace. It all boils down to building good relationships and trust. Building strong relationships with its employees, customers, and suppliers will continue to fuel SpunCast's success.
Continuous casting is the process used to solidify the molten steel ready for shaping into a huge range of final products. A ladle of steel is teamed or poured through a gas-tight refractory tube into a tundish. The tundish is a reservoir that allows the steel to flow at a controlled rate through further gas-tight refractory tubes and into a series of water-cooled copper moulds. With only the outer shell solidified, the steel is drawn from the bottom of the mould through a curved arrangement of support rolls and water sprays. It emerges horizontally in the form of a solid steel strand. At this point, it is cut to length using automatic gas burners. Depending on their size, these solid shapes are called billets, blooms, or slabs, and are now ready for shaping into finished products.
close.